So our first presentation for 2023 is going to be a little different than we've done in the past, and I'm looking forward to it. It's actually going to be an interview with Doug. I would ask Doug to come up at this point. W2VX. Let's give Doug a welcome. And Brian AI6US, come on up. So the way this is going to take place is Brian is actually going to interview Doug. And I'm really going to have fun with this because Doug's going to be difficult. Brian's going to be really creative. So have a good time.
Thanks.
Good evening, everybody.
1, 2, 3.
Oh, are we going to do karaoke?
Yes, indeed.
All right. Well, this year we did a lot of things in the vault, and one of the things that the members approved, what was it? I think it was September, you approved funds to do a major upgrade in the vault on the AC and DC. So this, basically, we're reporting back to you the money that you approved to improve the vault. What did we do in there? Now, Doug just returned from Hawaii. How was it, Doug?
Yeah,
I'm kidding.
Aloha.
Well, let's start out. There was a problem going on in the vault, and why was an update needed, and why did we ask for funds?
So the short answer is I went in to check the status of the batteries, the backup batteries in the vault, and in the process of doing that, saw a few things that needed improvement. In the DC side for serviceability and safety, and in essence, I couldn't remove the batteries to test them without shutting the entire system down. And based on that, I made some recommendations that we improve the ability to separate the various components on the DC side. And in the process of doing that, I leaned up against the AC fuse box that was sort of post-Vietnam vintage screw terminal, and it failed.
And we're looking at the old AC panel right now, and maybe you can have an idea why it needed to be updated. Oh, wait, the new one's on the left, the old one's on the right. Sorry about that. I'm joking. Come on.
We had those in the farmhouse that I lived in Iowa, and it hadn't been upgraded for at least 40 years when I lived there. So,
all right. So in addition to the power failure that happened in the vault, you went in there and then you noticed that there were some other needs. What were those needs?
Well, we had to upgrade the AC, so we replaced the panel. We isolated the DC. Let's go to the next slide, I think, right?
Right.
This is a view of the back of the racks. I can't go over there and point at anything, can I?
I'll just talk about what we see.
Okay. So in the top left-hand corner up there, that's the old AC panel, and their batteries are sitting on the floor, and we couldn't get to the back of the rack without stepping over the batteries and disconnecting them unnecessarily. So we've moved those. We moved them to the front of the rack into a place where they were easily accessible. We put in another panel to manage the various zones for the DC side. That red box that's slightly to the left, that's the low voltage disconnect, so that when we lose AC power and we go to DC backup, that in fact we don't drain the batteries to the point where they're actually damaged.
Let's see, we were talking about doing some cabling now. You're looking at me like I should be asking a different question. Oh, we didn't start the timer. We're trying to get this in 10 minutes. So how long have we been going?
I'm going to call it
1 minute.
8 minutes and 30 seconds.
Well, moving right along then. So we also identified some cabling needs that needed to be addressed.
8 minutes and 50 seconds. No.
Now tell us about the DC distribution that you came up with. You had some problems when you were trying to change out batteries, and you came up with a solution to provide a way to manage, do maintenance, and then also provide isolated power. So what do we have going on?
That is correct.
All right.
No, actually, so this is I always like to start out with a plan, even if it has to change midway. Up in the upper left is the AC outlet. It goes into a battery charger, which really is a DC UPS. So when AC fails, it basically stops providing power on the DC bus, and we rely on the backup batteries. And so there is a load center, and there's isolation between each of the various legs, and so there's 30 amp breakers that are there, and in the event that something shorts out, we will in fact knock the power out, and that's what we want. There's also, you see on the bottom, there's two 115 amp hour SLA batteries. It turns out that that really means that we have about 150 amp hours, because those SLAs are only good for about 50% discharge. Okay, and the repeater rack eats about 5 amps when it's quiescent, and it eats about 15 when it's actually transmitting. So we have about 20 to 24 hours, depending upon the amount of activity that's into the repeaters themselves. I think that that's cutting it close. We just had an outage, and we needed almost twice that.
Okay, now we have a internet system in there, and it has different needs than the repeaters.
They do. So we needed a 5-volt supply, and we wanted to make sure that we didn't. There were some ground loops that were causing a lot of interference because of the ground loops coming through these digital devices, and those support. What? I'm going to switch this on you.
Yeah. So these nodes will support All-Star and Echolink, and we also are going to be bringing Wires X back into this. But at this time, we are looking at All-Star and Echolink, and this is the way that the signals come from other nodes around the country and get introduced into our repeater.
Yeah, so the devices that you see on the left-hand side are the internet radio services that Brian just mentioned, and they were plugged into wall warts and a variety of other sources, and for some reason there was a ground loop. In the process of doing that, I decided that we should put in an isolated DC to DC bucker and a 5-volt bucker, and that we would run everything off of that so that we didn't have problems with ground loops.
And I'll say that's been highly successful. If any of you have been listening to the repeater and hear the All-Star and Echolink connections coming in now, they sound absolutely fantastic, and so thank you.
Thank God. Doug, it's scratching again. Doug, what do we do? Doug, I don't know, Brian. It's important for the coffee break net, Doug. Okay,
Well,
so this...
I'll just say that the internet connections sound great. It's the RF that's scratchy.
Yeah, we're still working on that.
We have a little discussion going on with PG&E right now, and as you know, I'm known as the Sea Beer from Meadow Vista, so I'm not really the one that's interfacing with PG&E right now. So we're working on the RF scratch. Right
Yeah, and
now.
I'm Mr. Nice Guy, and I'm not really leaning on him. So we're going to get somebody else to lean on PG&E. Anybody volunteering? So this is the front of the repeater before we did the servicing. It was evolutionary. Just say it like that.
Okay, so what happens every time something happens in the vault? One of us climbs in the car, drives down there, and determines, do we have a problem? What is the problem? And who to call to help fix a problem? So You know, we're putting on a lot of miles and a lot of drives down there, and I know who in the room has driven down to the vault at least once and hung out with us? Yeah, quite a few people have gone down to the vault. So it's
Who are we
fun.
going to call? Ghostbusters.
So
Dun, dun, dun,
from the
dun,
comfort
dun.
of our home, we may be able to do some stuff. So tell us about it, Doug. I think we have about 2 minutes left.
Yes, a minute and 39 seconds. So, yeah, I got tired of driving down there myself. So I thought, well, why don't we put in some telemetry? Let's look at whether the AC service is off. What is the current status of the charge in the batteries? Track the repeater duty. I've always wanted to do this, so every time somebody transmits, we've got some directional couplers. We can measure the amount of power going through the directional couplers. We can also look at the amount of DC current that's going on the bus out of the recharger and out of the batteries, and so we can get some idea what the health of the batteries is. It's turned out to be a little more complicated than I thought, but I'm still somewhat optimistic that we're going to get that done.
And what are we looking for now? We're starting to gather that data, but what are we going to do when we gather it?
Well, that's always the question about data. You don't really know what you're going to do with it until you've had an opportunity to evaluate whether it's worth anything. So seriously, I mean, that's kind of the way that I've always worked. I'm kind of a researcher, and it's like, let's collect the data and see if it means anything, and then what will we do with it to make things better.
So what Doug's trying to say is, I'm gathering data. He wants somebody else to pick the ball up and run with it. What our dream, my dream is to make this data available for people to see in a graphical interface. If you want to see what's going in the vault, you go to one of our web pages, and you can see what's going on in the vault. You'll see what's keyed up, how much power we're using, are we on backup power, and it's just, you're providing us some great tools. Now we need to figure out how to use them and how to make it available to people. We have one person, Phil in FS, who said, hey, I design things that take data onto graphics.
Yeah, basically visualization tools like Grafana and others are people that are in the club who are really smart about that kind of thing. I'll supply the raw data, and they'll make hopefully correct knowledge out of it that we can use going forward.
So this is just the simple thing that he came up with over coffee one morning. What are we looking at?
Wow. So really, the green boxes are voltage sources of some sort, either measuring current flows or power in antennas or coaxes. And the thing in the middle is an Arduino. That big, long, tall blue thing says Arduino on it. There's a bunch of analog to digital converters that are evaluating those voltages, and it sends it off to a Raspberry Pi that's a little more over here, kind of what would a woman call that color? Kind of mauve or pink or what? Salmon. Thank you. Salmon color. Yeah, thank you. Red, blue, green. And then out of the Raspberry Pi, we have it set up so that we can get into the Raspberry Pi through our home computers and look at reams of columnized data. And that's kind of as far as I have taken it. We have some of that data already being collected. I'm not sure how much I trust it, but we're on the path to getting real telemetry data.
All right. So we've come to the point where, do we have a few minutes just to see if there's any questions?
We're 2 minutes over.
All right. So hands up in the air if you want this conversation to continue, or do you want to go to break? Oh, okay. I guess there we go.
I'll go to break.
All right. So you hang right here. Okay. I'll go see who has a question. I see Smitty, and then I'll make my way around here.
First of all, thank you for all your work, especially this week with the weather. I mean, honestly.
Glad to do it.
You kept us on the air at times when we were limping along. And actually, that's one of my questions about battery health in general and your assessment today of where our DC bus is without shore power, given that, full transparency, the repeater lost power the other day. So just curious about the battery health and how long the repeater can run without shore power, give or take.
Well, yeah, so I tried to allude to that. I think that, we gave it a little bit more oxygen in the middle of the day when the power went out. It went out at about 4 a.m. around, I don't know, Rob came over with his generator and we gave it some juice for a couple of hours, and it lasted until about 10 minutes before the coffee break net.
So one of the things that we're talking about doing is putting in a cutoff, something that will cut off the amplifier, because that amplifier is just icing on the cake. And if we can cut that off sooner instead of having it run for 3.5 hours during the coffee break net, we have bought a whole lot more time of operation.
Yeah, and really the way to do this is put enough batteries in so that we don't have to do that.
Questions?
Seriously, that's the right solution.
Ray?
More do with the website and stuff too, but there had to have been changes. I noticed instead of having the Broadcastify link on the first page, it has listen to. And how is that link hooked up now?
That's something different than what we're talking about tonight, but we'll get a quick answer. When you click on Broadcastify or listen, where are we going?
Yeah, good question, Ray. Ray, that is actually still accessing Broadcastify. The only difference is instead of bringing up their player, it goes natively through the website. So rather than leaving the site and going to Broadcastify, it brings it right in.
The delay is something that we have no control over. That's how busy the Broadcastify servers are. Questions?
Now, here's why I actually did this. There's two reasons. One, this is a real big asset for the club, and it needs to run. I enjoy the coffee break nets. I enjoy the afternoon chatter on the repeaters. It brings us together, and we need to do something to make sure that this equipment runs regularly. We also support a lot of activities in the community, and it's important that we keep this thing up and running and make sure that it's safe for people to go in and do the work and service it and improve it. You don't want anybody going into this vault to watch the 75-inch TV and drink the beer and stuff like that, unless it's safe in there. Is it okay if I tell people about the beer keg? All right. Yeah. One more question.
Mr. Microphone.
Is there any plan or sight into getting more batteries so that you don't have the problem that we're having right now?
It's been thought of, but we haven't actually taken any steps to deciding what to do there, and that's just it's a future thing. The question is, how often would we expect to have a repeater outage for more than 24 hours? And if this is a once in a 20-year thing, then there isn't any reason to put more infrastructure in. It's kind of looking like it's going to happen more frequently, though.
And I was just going to add, we had always planned on a 24-hour, and if we saw it was going to continue past that, then we would bring in a generator. So that had been our prior plan. It just caught us a little off guard. We expected a couple more hours of battery. And so, we have to examine that for the future. Absolutely.
A lot of other...
If you had already knew the power was out, instead of waiting until things started to go to crap, you would have had less problem too.
Let me edit that. Beep.
So the 30-second response is, when I decided to put some telemetry in, I had to figure out how to make sure that the telemetry didn't go down when the power went down. So anyway, we're 15 minutes and 9 seconds.
Great.
We're done?
I think we're done unless you have any more questions. Excellent. Thank you very much, Doug.
Thank you very much. Thank you. Thank you.
You're not done yet.
Oh, yes, I am.
Can you flip back one slide?
I can't.
One slide back. I was just going to mention that I was going to have Doug help me put a monitoring system on my garage door so I know if it's up or down. I'll take care of it, Doug.
Thanks, great.
You're welcome. But thank you for the great presentation. And Brian, come on up. Let's give him a big hand. Great job. Thank you.